8 powers of I. Give me just a little bit on this. It's going to be a little bit different, but at the end, you're like, okay, we can do this. It's no big deal. But give me just a little bit to explain why everything is going to be done the way that you're going to do it. So, first off, before we even begin, let's talk about remainders. And notice that on all of these, what we are dividing by. There is a reason for that. We'll get to that in a little bit. So if we did this, and I said 22 over 4, there's a couple ways that you could have figured this out. You could have said, okay, 4 goes into 22 5 times, with how many left over? 2, right? 2. We're going to be dealing with the how many leftovers on today's lesson. So pretty much what I'm saying is I don't really care about the 5 and I don't care about the 4. All I really wanted to know was the 2. Now also, if you would have put this in the calculator and did 22 divided by 4, you would have received 5.5. Well, 0.5 is a half, right? And a half, when we are dealing with fourths, is 2 over 4. 2 over 4 is the same as 1 over 2, and 1 over 2 is the same as 0.5. Again, there's a reason why I'm saying that, but I'm not going to get to it right now. All right, let's go to the next one. 31 over 4. 4 goes into 31 7 times. I don't really care about the 7. All I just want to know is how many remainders I'd have. And the answer to that would be 3. Okay. Also, if you put 31 divided by 4 in the calculator, you get 7.75. Well, what is 0.75? 0.75 is 3/4. And again, all I really care is how many out of 4. So there we go on that one. Now 4 goes into 37 9 times. Don't really care about the 9. I just want to know how many is left over. And it would be 1. And if you put 37 divided by 4 in a calculator, you get 9.25, which is 1/4. So there's the 1. And let's change colors. On this one, 4 goes into 16 4 times, right? With no remainder. You would never ever write this on any kind of problem whatsoever. But for today's lesson, let's just say that we are. And then if we put 16 divided by 4 in a calculator, we get 4. If we had it in a special mode, we'd get 4.0. And then that would be 0 out of 4 also. That would be 0. Okay, so what I'm trying to get to before we even get to anything else, and it's going to be just a little bit before I get back to this information, but basically, if you're dividing by 4, you have 4 different possible outcomes. You could have where it goes into it evenly. You have 1 remainder, you have 2 remainder, or you have 3 remainder. Okay? Let's talk about that in just a little bit. Kind of set that to the side just for a little bit. Okay, now we're going to this. Again, bear with me, be patient. There is a reason why I'm doing all of this. Okay, so we've been dealing with i's and we've been dealing with I squares. Well, if it's I is just I, right? Can't really do anything with it. But does anybody remember what I squared is? That's right, it's -1. Okay, now what about I to the third? What does I to the third mean? I to the third means I times I times I. That's an I. Well, if I have 3 i's, then that means I have 2 i's. And what is I squared? Negative 1. So that would be negative 1I or just negative I. So I is just I. I squared is negative 1. I to the third is negative I. And what about I to the fourth? I to the fourth is like I, and I. After this one, I'm not going to write down 12 i's, okay? But that would be I squared and I squared. What's I squared? Negative 1. What's negative 1 times negative 1? A positive 1. So I to the fourth is a positive 1. Okay, now, what's I to the 5? Well, I to the 5 is I to the fourth with one more I, because that would make 5 i's, right? Do we know what I to the fourth is? Yes, we just found it. It's 1, which would be 1I or just I. What about I to the sixth? I to the sixth, I'm just going to stick with I to the fourth part of it, is I to the fourth with 2 more i's. The reason why I want to stick with I to the fourth is because I to the fourth is simple. I to the fourth is a positive 1. So that'd be a positive 1 with an I squared. Well, I don't want to do that. I to the fourth is a positive 1. I to the second is negative 1. Positive 1 times negative 1 is negative 1. Okay. I to the seventh is I to the fourth and I to the third. I to the fourth is a 1. I to the third is negative I, which makes this negative I. I to the eighth is I to the fourth and I to the fourth, because 4 plus 4 is 8, which is a positive 1 times a positive 1, which is a positive 1. Does anybody see what's happening yet? If you don't, bear with me for just a little bit longer. I to the ninth. I to the ninth is I to the fourth and I to the fourth and I to the 1. Well, if I to the fourth is 1 and I to the fourth is 1, and then we just have an I, then I to the ninth is the same thing as I. I to the 10th, I to the fourth, I to the fourth, I to the second. 1 times 1 times negative 1 is negative 1. I to the fourth, I to the fourth. So what's going on with these I to the fourths? Have you figured out that they're really not necessary? I don't care about that I to the fourth, and I don't care about that I to the fourth, because it's just a 1 times 1. What I care about is how many's left over after I take out my I to the fourths, which is I to the third, which is negative I. I to the fourth, I to the fourth, I to the fourth. 1 times 1 times 1, which is 1. Okay? Have you noticed something yet? If I just had one I, it was just I. And if I went I to the 1 to I to the 5, which is 4 more from I to the 1, we still get I. And if I go from I to the 5 to I to the 9th, which is 4 more from I to the 5th, I'd still get I. Same thing with I to the 6th is negative 1. I to the 10th is negative 1. I to the 7th is negative 1. I to the 11th is negative 1. I to the 8th, we don't have any remainders, do we? I to the 12th, we don't have any remainders. Okay, so here's the thing. If you've noticed, it's a cycle. It repeats. How many's in the cycle? 4 different answers are in the cycle. So Let's see if we can get it. Okay, first couple of one of these should be fairly easy because we've already talked about it before. But I to the fourth is that complete cycle of 4, so it's going to be a 1. I to the third is negative I. I to the second is negative 1. I to the seventh, if I do 7 over 4, I'd get 1 3/4. I'm looking at the 3. What is I to the third? Negative I. Here we go. Here's some bigger numbers. Okay. So if I take 24 and I divide by 4, I'd get 6.0. If I get 0.0, then that means I'm at the end of the cycle. And if I'm at the end of the cycle, I have a complete group of 4. If I have a complete group of 4, then my answer is going to be 1. 21 over 4, which would be 5 1/4. So I'm looking at the 1. Or if you use the calculator, it'd be 5.25. Okay. If I have a remainder of 1, that'd be I to the 1, and I to the 1 is just going to be I. 877 divided by 4. Okay. You can either get a calculator, which I don't have right now, but I do know that every group of 100 is a group of 4 because 4 goes into 125 times. So pretty much 877 over 4 is the same thing as 77 over 4. Now if I take out, and what about 40? 40 is a group of 4, so if I take out 40, I'd be left with 37 over 4, which would be 9 1/4. And that 1 is an I. Okay, on this one, like I was subtracting on this one, I was subtracting groups of 4. We cannot evaluate negative exponents, so I'm going to add a multiple of 4 that is bigger than my exponent to be able to get an equivalent answer. So because this is negative 1 right now, if I add 4 to it, I would get I to the positive 3. I to the negative 1 and I to the positive 3 are the same answer, which makes it negative I. I to the negative 8, I'm going to add 12 to it, which gives me I to the 4th and 1. I to the 327 is the same thing as I to the 27. If I take 24, because 4 goes into 24, it would be I to the 3rd, which would be negative I. I to the negative 70, I'm going to add 80, because 4 goes into 80, and 80 is a really easy number to work with. 80 minus 70 is 10, and now I'm going to actually subtract 8 and get squared and get negative 1. I to the negative 9, I'm going to add 12, get I to the 3rd, which is negative I. That's it. We're finished with Unit I.